All right, I'm going to continue to look at what we can do with Desmos and how we're going to use that as a utility to help. What we're going to do is we're going to continue in section 2 of chapter 4, and we're going to look at some of the more complex functions, specifically the exercises 21 through 48. And so we're going to look at these polynomials, and we're going to approximate the coordinates of the turning point and estimate any local extrema, and then look at some of the degrees of the functions and what we have going on. So the first function I want to look at is going to be function 24. And so let me put that up here on the blackboard for you here. And so 24, the function we're looking at is f of x is negative 1/8 x to the 4th plus 1/3 x cubed plus 5/4 x squared minus 3x plus 3. Notice this polynomial, we have each term of x really covered for a 4th degree polynomial. We have the x to the 4th, x to the 3rd, x squared, x to the 1st, and our x to the zeros. So let me pull up Desmos. Let's switch over to our graphs. There were our previous graphs. Let me clear these out. So you can clear them out by hitting the x over here. And so I'm going to hit f of x equals, now I'm going to type in negative 1. I'm going to use the slash by the question mark to get divided by 8. X shift 6 puts me into the power to the 4th plus 1 divided by 3. I have to use the right arrow to get out of the denominator. X cubed. Notice some things that are happening as I'm building this polynomial. The different terms start having some change coming. It's still a leading term as a 4th degree function, so, and with a negative, so the big N behavior will be in the negative direction. But adding this cubed term has added an inflection point in here and kind of a local maximum. All right, so what do we have here? We next have 5/4, so plus 5 divided by 4. Hit the right arrow to get out from the denominator, x squared. Ooh, I'm starting to go off the screen here. I might have to change my screen. Let's see what the minus 3x does, and then plus 3. And so I'm up a bit here, so I'm going to, with holding my mouse button down, the left mouse button down, I can drag the screen down. So I'm going to drag it down so I can see the turning points. Now this is a 4th degree polynomial, so it has at the most 3 turning points, and there's 1, there's 2, and there's 3. And so by using Desmos and clicking on those points, I can actually answer the question where it says approximate the coordinates of the turning points. And how many decimal places did they want here? Well, we can give it to 3 decimal places because that's what Desmos is doing. Negative 9 or negative 2 comma 9.3, 1 comma 1.458, and 3 comma 4.125. And if we look a little closer at these, we have an absolute maximum at 9.33. We have a relative or a local maximum at 4.125 and the 9.33. Right? These are both local maximums. This one also happens to be the absolute for the function. And we have a local minimum at 1.458. And so this 4th degree function gives us an example of 3 turning points, a local min, a local max, and an absolute maximum. And Desmos helps us see this pattern nicely.